Hello, everybody. I'm Jamie. I'm the organizer of EdinburghJS. Welcome back to Familiar Faces, and hello if this is your first time here at EdinburghJS. Tonight we have got two talks for you. We've got a lightning talk and then the main talk that everybody's here for. Firstly, before we start, thank you to our sponsors, Perk. Perk provide the beer, pizza and venue for us, and without their support we wouldn't be able to run a meetup of this size. There's a QR code just here. They're hiring. They seem to be constantly hiring, I think, which is good. It's good for us, good for you if you're looking for a job. So please do check it out. And if you use the QR code link, then they'll be able to tell that you've come via EdinburghJS, and that's a good thing. So tonight, the first talk, we're going to have a lightning talk. And just to say a few words about this talk, Luigi is going to do it, and he has come via our Speaker Launchpad program. So Scottish Technology Club, there's a banner just on the way in. We run a program for people who maybe haven't spoken at meetups before. So maybe you've spoken at a work event internally and you want to take that to the wider public. Maybe you haven't spoken anything before, or maybe you've just got something you want to share. We can provide some mentoring and feedback. So, you write your presentation, but we can give it a once over. You can practice it. We can help you find a topic even. So that's basically for anybody here that wants to do that. It's hopefully a really easy process. Yeah, and it's basically just so that we get more people involved with the community and feeling that they can kind of take ownership of the meetup and kind of use it. So yeah, on that note, Luigi, take it away. Cheers.
It's a company computer. It's fine.
Well, they can sue me.
They don't have that kind of money. It's fine.
Right. Hi everyone. I'm Luigi. I'm a data analyst at Ofcom, and I want to start out by asking you how many of you have published an app, data analysis, or any output thinking about how your audience would see it. Good. I didn't until I got through a data project that I've done recently. And first of all, I want to talk about why we use color at all. There are three main reasons why we want to do that. First of all, to distinguish categories. We want to make it very clear for our audience that we're talking about different things, and the immediate way is by making them in a different color. We want to encode magnitude and intensity, so a different color, a different shade might mean something in context. This is better, this is worse, this is bigger, this is smaller. Or we want to draw attention and drive focus. So we want a way, a path that the reader can follow, and we want our message to be conveyed through that media that is the color. The reality, though, is that someone in your audience can't see what you see. So the stats are that 1 in about 12 men and 1 in about 200 women can't see colors in the way everyone else sees it. So to size it, in a room full of 50 people, there is about 2 to 4 people that can't see the colors in the way you are seeing it. So it's very common, much more common than what you think. And if in a room full of 50 people, 2 to 4 people can't see the message you're trying to convey, and they are the decision makers, then you're failing from the start. You won't get through them, and you won't get, hopefully, the decision that you're trying to influence. There are several kinds of color blindness. There is the blue-green, the red-yellow, there is the total one, and there are various degrees of gravity for each of them. So it's possible that a rainbow appears to someone as just 2 colors, whereas everyone else sees a rainbow, every possible color. As I said, I work at Ofcom, and I have fun trying to make the Ofcom logo looking like what it looks like for a colorblind people in one of the most common color blindness. And as you can see, on the left, there is the regular logo. On the right, there is how it appears on for a colorblind person. And as you can see, the visual identity is very different. Red and green scales are very common, from traffic lights to the default on Excel heat maps. It's the common concept of bad versus good that in every kind of visual tends to be associated with that. And if you can't see the story and follow the logic, how you're going to action what you're trying to communicate. So a few months ago, I did a data project through the Data Lab, which is an organization in Edinburgh University with a mentor, with a mentee, because I'm trying to give back to the data community. And we used a data set called the Co-Benefit Atlas, which is a data set that tries to measure the indirect benefits of climate policies across the UK. Things like reduction in pollution, more active ways of transport, etc., which are benefits that are very difficult to capture from a numerical value. And the effort that was made there was to try to capture this kind of indirect benefits to inform policies. So we took this data, we paired it up with the Scottish Index of Multiple Deprivation, which is again a very vast data set at the same level of granularity that gives a deprivation index for various areas of Scotland. And essentially, we discovered that the spatial relationship between the co-benefits and the multiple deprivation meant that essentially more rural areas would get less co-benefits intuitively, because a rural area has less traffic, and therefore one of the main drivers of the co-benefits is traffic reduction. If you start from a lower basis point, you get less benefits. We examined various areas in Scotland, from Glasgow to Edinburgh to Fife and borders. I live in Fife, so I was really directly interested in what was happening in my area. But given that exactly we discovered this rural factor, we moved on to look in particular at Glasgow, which is heavily urbanized, and some areas look a bit better than others. After we did our analysis, the immediate thought was, how do we represent this? Because the key message here is that the co-benefits don't distribute equally. So the message, which is not all climate benefits are distributed equal, needed something to convey the message immediately without the necessity to explain, considering the space and time we had available to explain our analysis. And so we decided, by building our maps, to, after testing a few options, to land on this color, which is 475841, which is a hue of green that we selected because sorts of recalls of Scotland, right? Like trees, forests, green environments, a bit familiar, looks familiar. It's legible for everyone. You don't need to be, even if you are colorblind with a grade, you can see the message. And it was an intentional choice. There is no default for that. And the map itself, without a legend, it's clearly visible, and the meaning is immediately available for all audiences. So these are the maps that we plotted. As you can see, 4 areas of Scotland, Fife, Glasgow, Edinburgh, and the borders. And even if you have not read the paper, you can see that there are some darker areas, in particular in areas that we can consider a bit deprived, like, for example, Leith and Craigmillar in Edinburgh. And that's the key message of the paper. Not all climate benefits distribute equally. And you can immediately see, without any legend and anything, that darker means something. And then you go through that. And so I want to leave with just 3 things to take away from all of this. First of all, if your design excludes parts of your audience, then that's a problem to start with. And it's an equity problem. Monochrome is heavily underrated. Many people tend to default to colorful choices, rainbow palettes, all colors of the rainbow, and etc. Whereas, for example, in some cases, it might be more appropriate to go for a scale of a color. And there is plenty of tools that, in any context, even development, you can use to check your outputs, and it only takes 30 seconds, and maybe you have done yourself and some other people a favor by just checking that what they can see is actually what you mean. And on that note, thank you very much. If there is any questions. No?
Well, it turns off, I think, in a minute. Cool. Thank you very much.
Thank you.
One of the things that I always think as web developers, and one of the things about EdinburghJS is that as a web developer, you're often tasked with things, and you've got to know stuff about other things too. It isn't just how to get pixels on a web page. It's okay. Well, how do people actually use it? Let's look at colors. Let's look at fonts and whatever. So I think it's really important to know these things. So thank you for that. Does anybody in the audience have any questions? I'll hand you this mic, and I'll use that one.
Thank you. I was interested in how do you balance the trade-offs of using a monochrome, and obviously it has a problem with the contrast and everything, and using the colors.
Yeah, I mean, in this case, we didn't need to check really for contrast because the baseline was quite clear. I mean, after trying a few different starting colors, the contrast checker was good in mostly all of them. But yeah, there is the problem in particular, if you overpose text on your color, like if the map, for example, had the region, the area names on it, then it would have been a problem. But there are tools that can do that contrast checking for you, and there are acceptable guidelines within which it will tell you, this is good enough or not.
But would you say then that the default preference should be monochrome, at least in this case?
I'm an economist by training, so my default answer is it depends. In the sense, it depends what you're trying to achieve. In this context, it made sense. In other contexts where you have categorized values, for example, different categories, it's possible that you might want to use different colors to represent different categories, especially if there are many. Here, I've not gone into details, but essentially our numbers were distributed in quintiles. That's why 5 variations from the original color. So there is something in graphic design that it's either 3s or 5s that are manageable. After that, it's a bit different. So it depends on the context. But generally speaking, I found after this project in particular that next time I'm going to think monochrome first. And then if I need, I'll go for other colors.
Okay, thank you. It's not working.
There is.
Try that one.
The two figures, men and women added together, seem to add up to about 4.5%. So you're basically talking about 1 in 20 of the audience across both sexes gain from doing this. But I'm wondering, is that a greater gain for the provider of the web page or the information or whatever than the loss of the intensity and the quality of communication that is conveyed by having a full spectrum of colours? Because obviously red and green aren't just arbitrary choices, they have a psychological meaning. So I'm kind of thinking of the analogy with language. You cater for other languages by having a button saying translate to French. Could that not be the solution here?
Or you can learn 4 languages like I did. Yes, there could be. I mean, you can switch on dark mode, right? I mean, there could be nothing stopping you into creating a color blindness mode for whatever you are designing, and then you make the user aware of that choice, and then in that context, but you still need to think of that context. That's probably like you're gonna get two versions of the same thing, and then you need to maintain them. So again, it depends on the context. And I'm a bit in difficulty talking about software development because I'm not a software developer. But in my case, going red or green or monochrome would have been conveying the same message. We were just saying, look at these areas, they are important, and whichever way we would have done it, we would have reached either 94, 95% of the population or maybe 100. So we went for 100.
It's just finding the least worst choice.
It's always a matter of equilibrium, right? Again, economics is the science that studies the perfect allocation of scarce resources. That's what you're doing. Your scarce resource is the attention of the user, and you need to maximize that as best as you can.
Cool. Anybody else?
There is John here.
Thank you. Are you aware of the grammar of graphics paradigm of Leland Wilkinson and popularized by Hadley Wickham?
Yeah, generally, yes.
Because yes, so you've got this idea that it's saying data visualization is a consistent application of mapping rules from features of the data to features of the graph.
Yes.
And you can see this as a series of lines that go from the data features to the graphical features.
Yeah.
This then leads to a really useful heuristic for issues of color. You can have one data feature that maps onto two or more graphical features.
Yeah.
So you can use color and you can also use saturation. You can use this and you can use that. So that, is that useful for as a heuristic? If you're going to use color, make sure that same information is conveyed through another graphical feature.
100%. Again, it depends on the context. It depends on what you're trying to represent. It's famous, we were talking elections earlier, like land doesn't vote, people do, right? So what do you see on newspapers the day after elections? Big regions colored as if, and then you look at the density of the population and that's a completely different picture. So there's always the risk of misleading your audience through the way you choose to represent your data, and the mappings that you mentioned are quite necessary. Again, depending on context, depending on what you're trying to do, there are different ways and features that you can put together to. One thing that I do, for example, in my data projects, if I decide that a variable is blue, a particular shade of blue, and I talk about that variable across different visuals, then that variable is always the same color, because otherwise your audience will be finding around, oh my God, what's that meaning, etc. So there are ways that you can guide your audience, and again, the principles are like you need to help your audience understanding what you're trying to do.
Cool. Thanks for the questions, and thanks to you.
Thank you.
Cheers. So just to reiterate, if you want to do that, come and speak to me after. We're going to do Speaker Launchpad again starting in September, and we can line you up for a slot at EdinburghJS. Doesn't need to be strictly JS. It can be databases, can be accessibility, stuff that JavaScript people might find interesting is the kind of key criteria. So next up, we've got Sara talking about emulation in JavaScript.
Oh, you're going to have to stand there and make small talk for a bit.
All right, okay. So if you're interested in supporting Scottish Technology Club and the Edinburgh JS Meetup, there's a QR code on the banner out there that you can scan. I send a bulletin every Monday with all the events I can find in Scotland for people who are interested in tech, plus lots of blogs and vlogs and so on that people write. For instance, John's blog, very interesting all the time. You consistent blogger, Sandor, you do blogs as well. I just try and include as much as I can, just to kind of you meet people here, you kind of want to know what they're up to afterwards, and doing that I think is a nice way to bring the community together. So scan that QR code. We've also got a patron supporters page if you want to contribute a little bit of money to help cover the running costs of the group. Is that enough blurb for you to get?
I think so, yeah, but...
Cool.
Oh no, oh no. Okay, let me just reload this. Because I forgot what is
What are the controls?
the controls for showing this. And no, it is not enough, I'm so sorry. I can make... I'm just clicking every button right now on my computer. Does anyone know the control to show the speaker view? Oh, there we go. It was that one. Don't know which one that one was, but that's cool. Okay. There we go. Cool. Can everyone hear me okay? Or do I need a mic?
All good? Yep. Cool.
Oh no, I have that mic.
Yeah, there's multiple audio systems.
there are
Cool.
multiple
Anyway, right. Cheers.
So, hi everyone. Thank you for coming, taking time out of your day during the World Cup. I appreciate it. My name is Sara. Give me a second, just because this thing is gonna screw it up. Hi, my name's Sara. I came from London, and I am originally from Portugal. I work at a very small company in London. We're hiring one front-end engineer. So if that's something you would like, you don't have to move. I would not ask you this. Do not do this. Yeah, no, that's about it. I have a strong hatred for the Berlin airport. If anyone has ever been to the Berlin airport, they will understand. And if you have, please come talk to me. I used to live in Berlin. Fuck that place. Cool. So, now that we got that out of the way, I'm going to talk about, so this talk started as me being like, okay, I'm going to build a Game Boy emulator in JavaScript. But life doesn't always happen the way you want it to happen. And as you can see by the title of the talk, it ended up being building an emulator in JavaScript. So I started with this idea, and then what I come to realize is that building emulators is really hard, but like absurdly hard for someone who doesn't have like a college degree or something, or a university degree. I barely finished high school, like by the claws of my teeth. So it was it was a very different thing from what I was doing, right? Like most of what I do is Node and JavaScript and CSS and all the front-end full-stack stuff. It was asking me to do things that I just never done with JavaScript. So it ended up being building an emulator with JavaScript, which I would like to think is good enough. You may disagree, and that's on you. That's your prerogative. But yeah, so I ended up building an emulator with JavaScript. This was, I just want to make it very clear that I know you can just ask Claude to do it right now. Or Codex. I don't know if you can ask Gemini, I'm going to be honest. But this was in like 2024. So it was a lot of Googling. Yeah, so I'm going to walk you through my experience with building it. I know things are different now because of the AIs, but yes. Okay, I want to start with this slide because it looks cool. So what I'm about to show you is completely legal. There is two reasons that I want to have this slide here. One of them is that, again, it looks cool to have this in a talk. I saw a friend of mine put it, and I was like, I got to find a way to do it. And second of all, is I think there's a lot of misunderstanding on what is illegal and what is legal when it comes to emulation, and it's Nintendo's fault. So emulation in itself is completely legal. So I don't know the precedent for every country, but in the US, which we all live in the US whether we want it or not, this all started in the 2000s after Sony released the PS1. There was this company called Bleep. I'm not fucking with this. It was a real company, and they decided to name themselves Bleep. And they went to Sony, and they were like, we want to make an emulator for MacBooks. And Sony was like, no. Like, I'm just not going to give you our code. So they reverse engineered it and made an emulator that ran on Mac OS, which I think is really funny because now I can't play anything on this computer. I tried to play Final Fantasy VII, the original one, and it lagged. And this was a PlayStation 1 game. So they released it. There's like this video of like Steve Jobs being like, we have a PlayStation 1 emulator. It's so surreal. So they released it, and Sony was like, you can't do that. So they sued them. And it was basically decided because they didn't steal any code, it was all protected under reverse engineering. So this is something that is incredible, that's protected at least I think it's protected pretty much. I think it's protected here. I think you're fine. So as long as you don't use proprietary code, and that's why a lot of emulators, if you've ever used one, ask you for the BIOS, because that's proprietary. I mean, you can find it on the internet really easily, but it is technically proprietary. So that's the story of that. And you wonder, what happened to Bleep? Well, they got bought by Sony, because Sony was like, shit, we lost. So they bought them. So I think everyone won. Weirdly enough, yeah. Everyone won in this story. Yeah. So with that said, do not fuck with Nintendo. Just don't. Like, it's not worth it. They will sue you, even if they're wrong. And you will be extradited to the United States, even if you're not American. It doesn't matter. Do not fuck with, do not make an emulator of Nintendo things. Just don't. I am not a lawyer, though. I think you could tell by my, I'm definitely not a lawyer. But I do know that emulation is legal. Still, not worth it. Okay, so Owen here has used emulation for any sort of things, either for retro games or for retro computers, whatever it is. Okay, cool. Oh, that's actually a lot of hands. You're all going to jail. You've downloaded a BIOS from the internet. Okay, cool. So I actually have a lot of these. Like, I got into a weird hole about a year ago, and I actually ended up buying a lot of these like retro handheld devices that bring me a lot of joy. And there are two types of emulation. This makes sense. This will make sense, I promise. There are two types of emulation. So there's hardware emulation, and that is something that is usually called, in the emulation scene, and by that I mean the subreddit, it is called FPGA. So an FPGA, basically what it tries to do, and an example of this is the products from a company called Analog. They make an N64 and they make like Analog Pocket, which is an FPGA. And what that means is you can put a Game Boy cartridge in it and it will work, because it's pretending to be a Game Boy on a chip level. This is not what I'm trying to do. I can barely solder two things together. But that is basically the concept of it. It's like you are, in an electronical way, tricking it and basically being like, you are a Game Boy. And then there's software-based. That is what we're talking about. So software-based is 90% of them, especially the cheap ones that I have. So I would say, yeah, probably like 98% are software-based. And what that means is the hardware is just fucking Raspberry Pi if you want it to be. Like, it's fine. Like, it can be an ESP32, good luck. It can be an Arduino, doesn't matter. What matters is the software you put into it, right? So you give it a ROM, you give it a game or whatever it is, and you write a layer of software that basically tells it, pretend to be a Game Boy. So there are two different ways of pretending to be a Game Boy, basically. Okay, and you must be wondering why in JavaScript? I don't have an answer for you. I was just like, why not? It was the thing that I knew the most. And I thought about doing it in Rust, but then I saw emulators in Rust, and the code is just as bad. So I was like, I don't feel like I gain anything out of doing it in Rust, except that I can tell people that I did it in Rust, and they will respect me, even though it's basically the same. But yes, Rust is good. Actually, it is. I do like Rust. OK, so I did not make it a Game Boy emulator. What I did was make a Chip 8 emulator. I had never heard of Chip 8 before, but Chip 8 is basically what you use if you want to learn how to make emulators. It's the easiest one to get started with. It's like baby's first emulator. So if you've ever heard of something called Pico 8, or there's another one, but there's one guy there in the back it just does this to everything I'm saying. Bless. He's like, yes, I've heard of it. And I'm like, yes. So Pico 8 is a fantasy console. So what that means is that it doesn't exist. What that means is that it's just a bunch of code that you run and pretends to be a console. And Chip 8 is basically the same thing. So Chip 8 was never really a console on itself. I mean, some people have made it into a console, but the idea of it was just an open source set of instructions, basically. And you know it's European. It was made by the French. God bless their soul. So Chip 8 is like from the 70s. It's incredibly simple. Nothing is simple, especially when it comes to this. But compared to what we do now, and compared to the PlayStation 1, compared to even the Nintendo Entertainment System, it is a very simple emulator. Like, it only has like 8 bits, for example. Okay, so if you think of any console you have ever owned, except the Wii, if you've ever owned the Wii, it mostly has 4 things, right? It has the chips, whatever that may be. Right now, just no RAM, because you can't have RAM anymore. We had too much RAM. Yes, so you basically have the chips, all of the graphics and all of the sound chips and all of that stuff. You have a screen that you need to plug it into, or it comes pre-plugged, you know, like handhelds, like a Steam Deck, for example, comes pre-plugged. I mean, that's literally how it works. There's a ribbon cable in the back. You can unplug it if you want. Don't do that. It has a keyboard or a mouse pad or whatever it is. Again, can come plugged or unplugged, the Steam Deck. And it makes beeps and bops, right? There's, of course, things like the Wii, which have way more stuff, and like the Kinect. Anyone remember the Kinect? No, I'm sorry. So, that was a great idea. Project management ruined it. So, but if you think about it, up until now, like until, you know, you get Oculus and stuff like, rest in peace, until you get like, you know, all of the, I don't even know the name anymore, and just Oculus, you know what I mean. So until you get that, for example, like it's basically this, right? You need to plug it into something, or it comes pre-plugged. You have a keyboard or a mouse or whatever you want to input in it, and you have sound. That's the core idea of what a console is, right? Any type of console, except the Wii, because the Wii. But for example, like thinking of the Wii, it is very interesting. There's one of the best emulators there is in terms of like, does it work on everything, is Dolphin emulator. The Dolphin emulator is an emulator for the Wii and the GameCube, and it actually emulates nunchucks better than like a Wii thing, because the Wii little camera thing was supposed to be on top of your TV. Good luck putting that on top of like a flat screen, right? So you have to put it like on the bottom, and then you have to play like this. So it actually emulates that way better with your camera, which is really interesting. Also, that's how I found out that the Wii is just a beefed up GameCube, and the Wii U is just a beefed up Wii. They're all the same. Like a Wii U can play GameCube games, which, I mean, not from the disc, because, you know, they have that small ass thing. But yeah, okay, so we start with the screen, right? The screen is the one that makes the most sense in JavaScript. You know, you use Canvas. I know Canvas is scary. I am terrified of Canvas because it is very declarative, but it's a very small screen. So two things. Again, monochrome screen. There you go. And it is 64 by 32 pixels, which is, at least to me, imperceptible to my eye. I cannot, just cannot. And it is completely monochrome, which means that you can map it to anything you want. Like if you want it to be black and white, which is what I did, that's fine. If you want it to be red and yellow, you can do that. I don't know why you would, but you can give it a hot dog theme, so that's fine. Okay, cool. So how do we do that? So the first thing is just we create a class called screen, and we give it a display. So again, if I go back, 64 by 32, so we create an array of 32 by 64, and we fill it with zeros. Since it's monochrome, it's either black or white. There's no grays. There's no like in between. It's either 0 or 1, so that ends up being the easiest way to go about it. You just give it a 0, and then when you toggle it to 1, you know, the color comes. And then you pass the scale, because again, it is imperceptible to the human eye. And then you just get the context of the camera, and you pass the colors. In my case, I passed the fill to white, the fill to black, and the background to white. And then the calls, you give it the width and the height, which is the calls time, to, like, you know, like 32 or 64 times the scale. Okay. Okay, so how do you actually show pixels? And this is something that when I was thinking about doing the Game Boy emulator, it really scared me, because I thought that in general, the way emulators worked is, let's say you have Super Mario Land or something for the Game Boy. You would have to actually draw every pixel of Super Mario Land on a canvas. And for some reason, that was the part that I was like, nah, fuck this, I can't do this. Turns out that's not how it works. I mean, in here, kind of, because there's only like 32 by 64. But in general, the way emulators work is that they have a big old sprite sheet. And from that, they will read little parts and put it in your screen. So you don't actually just create little pixels every time. Okay, so, but in this case, how do you set the pixels? Okay, so you have an X and Y coordinate. So this is the pixel you want to set. And you get that from the pixel location. So you get X plus Y times the calls, and that's it. Okay, cool. So what is this? What is that shit there? Okay, so basically, chip 8 uses something called XOR, which I will get to in the future. And this basically means if the pixel is on, turn it off. If the pixel is off, turn it on. That's it. And then you return, is this on or not? Okay, that makes sense? Cool. Then you have sound. The sound thing also scares the living shit out of me. So the good thing about Pico 8 is that it only has one sound. It only has beeps. It doesn't boop. actually, like if you look at like JavaScript emulators for Game Boy, most of them are like, the sound doesn't work. And I'm like, you know what, fair. Like, I don't want to fucking do that. So it only has one sound, so that's quite easy for us to achieve. So it's basically on or off the same way, right? So, okay, so let's create a class called speaker. We get the audio context. We set the oscillator to null, which basically the oscillator is what we're going to use to say is it playing or not. So it starts as null. And then you do all of the boilerplate of starting a new audio context, creating the gain, giving it the destination, and blah, blah, blah. This is all like just, literally, I think all of this is just boilerplate for the audio context, which basically sets it, creates it, you know, like the canvas. And then how do you actually play this, right? So let's say you get an instruction that says play a beep. And you say, OK, if there is no oscillator, it means it's off, so we're not playing anything. So you want to basically create a new oscillator, set a value at this time, and basically say the oscillator play this sound. So, and the sound, set value at time, and the value is 440. How did I get to this value? It's a magical value that people realize on the internet is what they intended it to do. So you can see that it only makes one sound. So you can see how far this would get, like if you had to do something like this and figure out how to map every sound to it. And then you set, no. And then you set the oscillator type. So there are several types of oscillators. So a square does this. And then you have like a saw, which does terrible, terrible things to your ears. And you have better ones. But the idea of a square is that it does beep and then stops. So there's no like beep. It's just beep, and that's it. That's why you use that one, because that's how they intended it to use. And then you connect it, and then you start it. And that's it, right? Because it's, again, just has one sound. And now we get to the CPU. OK, so the CPU is usually like the heart, like it's the part that has the most amount of stuff. And you have, in this particular emulator, in chip 8, you have 4,096 memory locations, and each of them are 8 bits. OK, so if you split this into parts, what the fuck is a memory location? It's basically a place in memory where you can save something, like someone's high score, how many lives they have, something like this. Anything you want to save, this is the number of things you can save it to, like the number of memory places you can save it to. And all of them are 8-bit. OK, so what does 8-bit mean in this case? Like, back in the 90s, there was this huge thing about the console wars and the bit wars. My parents hated consoles, but I've learned this through my adult life. And basically, like, the NES, for example, was an 8-bit console. And for example, the SNES was a 16-bit console. The main difference here, in a very broad way, this is not me going deep into it, but 8 bits can only hold numbers up to 255. So you would have a lot of games that actually, if you reach like 255, would like just go back to 0 or something. Like, and that was because it just couldn't, just didn't know how. Like, it could if you just joined a bunch of them, but you know. And 16-bit goes much, much higher. I do not know the exact number. And it has, yeah, and again, it has 16 8-bit data registers. OK, cool. So this is the game we're making, which is just, I mean, we're not making the game. This is just, it's just Arkanoid or Breakout. Depends on what you know it for. And when I saw this game was made in, I think, Z or C. I know they're different things, but I don't remember exactly which one it was. This is completely CC0. It's on the internet. You can look it up. But I thought that, like, I looked at the code since it was CC0, and I was like, OK, then I guess I need to read this code pretending I understand as JavaScript, right? So I was completely wrong, because turns out you don't have the code for most games. And what you need to do is read it as an int16 array, which is super doable in JavaScript. And so from the actual source code, when you upload it from the file, you get this, which is a bunch of numbers, which, if you look at it, none of them are bigger than 255. But this was the point where I looked at it, and I was like, TypeScript can't help me anymore. Like, I'm fucked. Like, I looked at this, and I was like, an array of numbers. Isn't that great? Great. So this is actually what you're going to be parsing in itself. And it usually, to save on space, it usually uses something called a hexadecimal notation. If you think, oh, isn't that like hex colors? Yes, that's exactly the same thing. So I was actually thinking, like, how do I explain hexadecimal notation? My partner was like, colors. And I'm like, oh, yeah. God damn it. That makes sense. So I would say in 99% of your life, you use decimal, which is 0 to 9. And sometimes we use hexadecimal, which is 0 to F. The main difference is to show 11, for example, you would need to say 1 and 1, which would be 2 bits. To say 11 in hexadecimal, you would say A. Wait. No, you would say B. So it goes from 0 to 15, which is better. Then you also have binary, which is zeros and ones, which we all know. Do not just, I mean, you know what it is, doesn't mean you have used it. But then you have hex colors, which are our biggest example, I think. I think everyone has used them. So this is the badass color, which we all know, obviously. So if you look at this, you get BA, DA, and 5.5. But actually, before we do this, you can think of like FFF. FFF is white. Yes. FFF is white, and 0000 is black. And if you think about it, 000 just maps to RGB 000. And FFF maps to 255, 255, 255. Because you have two Fs, and 2, 2, and 2, and 15, 255. I will explain that part. But yes. OK, so so when you have something like that, it's called a nibble, which I'm sure there's another name. I did not look it up because this name brings me joy. So you have a B, and you have A, and we know that A maps to 15, right? And we know that, no, A maps to 10, and B maps to 11. So what do we do with this? To convert it into a decimal, we get 10 times, so we get 10, which is the number of A, times 16, and to the number to 0, which just means 10 times 16, and if it's on the first, so this is 0, this is 1. If it's there, we put it by the power of 1. This is the kind of thing that you like look at it and you're like, this doesn't make any sense. But I promise you, if you do like 4 or 5 of them, they start making sense. So you end up with 11 times 16 and 10 times 1, because again, 16 to the power of 0 is 1, which ends up with 186. And that's how you end up with 255 as well. So if you want to do with all of them, then you end up with 218. And then you end up with 85, which gives you RGB. So basically, if you think about it, and you have no reason to think about it, I'm going to be honest, you can really make X look like RGB, and you can gain the power my partner has of looking at an X color and knowing what it means. She uses it a lot at parties. So, OK, cool. So how does this actually work? And how does it work is we have instructions. So basically, all of these numbers that we saw before are different kinds of instructions for the CPU to do, whether that be clear the screen, whether that be play the boop, whether that be clear the screen. What next? OK, so this is the Wikipedia page. I don't have to tell you what this is, but I do have to get my mouse in here. OK, cool. So this is the Wikipedia page of chip 8. The reason I'm here is because this is not it. No. Don't read it, because I may have said something wrong. OK, so instructions. Instructions are all the different types of understandings that the emulator needs to have, because it will be told what to do. So for that, we have opcodes. And opcodes, OK, in this case, for example, if you have n and n just means any number, basically. But if we look for one, OK, exactly. So this one, it means 00E0. If you get this, so if you turn that number, which is, let's say, 180, into a hexadecimal, and it gives you this means you have to tell chip 8 to clear the screen. So what do you do with all of this, right? So you have a bunch of these, right? And you have to go through all of them. You can think of them as functions as well. So you basically just like, first of all, I need to click outside of the iframe. There we go. We just tell the computer what to do. But we have to tell it to do many, many, many things, right? There's like, I think like 200 instructions, and you can imagine how many there are on like a PlayStation 1, for example. So how do we, in JavaScript, tell a bunch of things, like get a number, get something in, and then flip on it? We use a gigantic switch statement, which was also done in Rust. So that's why I ended up not using Rust. That was the only reason, because I clearly know Rust very well. So, OK, so we need to have a function called execute instruction. That's just the example I have done. So, and for that, we go through every single part of the numbers that we've got, and we're like, OK, we need to execute this instruction. What is it supposed to do? And every time we increment the program counter by 2 bytes, There is a reason here. Let me just scroll it here. Because each instruction is 16-bit. Cool. So it means it's 2 8-bit. So this means that every time it runs, we go to the next one, and this runs on a loop 60 times per second. Okay, so, and now you look at that and you're like, what the hell is that? So, this is when we get to ternary operators. But first, this basically means, okay, I want X, and I get the opcode, so basically the number, the instruction, and yeah. So I get that, and I do an end there. And you're wondering what that end is. So basically, let's say you get 0FFF, and you check the opcode, and it's 0F00. This means we only care about the one that has an F in it. We can ignore everything else, basically. So we're just getting that, and we're getting like the second nibble from it. This was just a lot of try and error, I'm gonna be honest with you. Okay, cool, so then we switch on that, and we say, okay, like if it matches this, then this means that this key is pressed. This is it for every single one. Does this make sense, kind of? Okay, cool. This is what you need to do for every single one. And if you're wondering the end, we're gonna learn about bitwise operators, not the other thing that I said. So, bitwise operators, I remember like being in London in a cafe, like, I know this sounds fancy, but it wasn't. It was probably like a fucking Narrow or something. And I was just like sitting outside and like trying to learn about bitwise operators and being like, what the fuck is this? Okay, so you have an end, which is the one that I showed you. And this means both things have to be positive. So we're doing this with, you know, zeros and ones because it's easier to understand. Both things have to be positive. If you have a 1 and a 0 and a 1 and a 1, then you only get the 1 and then a 0 because that one is negative. This one means or. We have this in JavaScript as well. So if any of them are a 1 in this case, oh, if you're wondering what the 0x is, that's the way JavaScript can tell something is hexadecimal, because otherwise it will just think it's numbers. I forgot to mention that. So that's the or is or. And then you have XOR, which is the opposite. So basic, you know, yeah, it's basically the opposite. So if you get 1, 1, and 1, 0, then you just get 1 as well. Cool. Am I going? Cool. Okay, cool. So we have actually seen this. I don't know why it's here again. Okay, so let's say that you get 0x18 out of that, out of all of the stuff that we showed for that x, for example, then you basically say, okay, start the sound timer at this register. So these are all, the register is just an array of things, basically. And yes, so for example, E again is rendered that clear. So if you want to see all the code, it's just literally a bunch of switch statements. There's literally nothing to it. It's mostly about perseverance than anything else, I'm going to be honest with you. Okay, so this is the emulator, which is just breakout. Whoa. Yeah, there we go, and it works. And it's fundamentally breakout, but very bad. It does have sound. It has one boop that it likes to make, and it goes to the other side, and that's it. And I was so incredibly impressed when this showed up. You can install it if you want. It's just called Chippy. I don't know why you would, but you know, I was like, yeah, why not? Is there anything more useless that I can do with my life? There was, in fact. So yeah, that's it. That's all I have for you. Thank you so much. If you want to check out the slides, they're online, so you can just scan that QR code. And if you want to go to my Blue Sky, I don't really post in it much. But yeah, that's about it. Thank you so much for having me. 28 minutes. Okay, cool.
Thank you. Yeah, I always think it's really interesting when you you fixate a project and you're, oh, I'm going to write this thing, you know, that is scratching the itch that I've got for, you know, like memories of console or whatever. Cool.
And I'm going to make it like as anyone can use it. And now anyone can pass the scale, and look, there's no reason for it.
Yeah, exactly. Cool. Does anybody have any questions about emulators, JavaScript?
JavaScript. Yeah?
Stay in the back.
Do not shame me.
Yeah, I was wondering if you, obviously apart from like a very interesting story for a presentation, like, did you think that you got a lot out of the experience of building the simulator in JavaScript?
Honestly, yeah. And a lot of the reason is I wanted to understand how they worked. Like, did I get anything usable for my job? No. like, did I get anything usable for me as a person, as a growth individual? Yes. Mostly because I wanted to understand how they worked. I learned about bitwise operators that I'd never used before. Oh, I did learn how to make, like, the hex. No, I didn't get anything useful for my job. I'm just going to say it. But I don't think, like, everything you do has to be useful for your job. Like, I do a bunch of shit with electronics that will never be used at my job. But yeah, I think as a person, I was very proud, so that's good.
Okay, cool. Thank you.
Awesome. Cool. Thank you very much.
You're very welcome.
Right. Thank you for coming tonight, everybody. I have no idea how much pizza and beer there's left, but please feel free. It needs to either be eaten here or taken away. So if you fancy pocketing some pizza, do that. Remember, Perk are hiring. I have booked a table in the Hanging Bat at around about 8 o'clock. So if people want to get together in a group and head over there, it's under the name of Jamie and EdinburghJS. Next month, in July, I'm organising a social, and I'm going to invite some other meetups as well. So it'll be a Scottish Technology Club social. I think that is going to be on Thursday, the 16th of July, to avoid any kind of World Cup conflicts, which they pointed out to me when I WhatsApped them. They were, "Are you sure?" I was like, "Let's change dates." So I've organised that to be conflict-free, and I will post that on the Luma and the meetup in the next couple of days and invite you all. Cool. So that's basically it for talks until September. So I hopefully will see you at the social and yeah, later in the year. Cheers.
Yeah, we're good.